As the sun rises, the true scale of the underwater highway becomes clear, a monumental feat of engineering.
Surface, we have contact, increasing torque to maximum. We are through the basalt layer.
This massive underwater excavation represents a new era of deep-sea engineering.
Far beneath the waves, where sunlight cannot reach, the Leviathan awakens, pushing the boundaries of engineering into the abyssal depths. The Leviathan sphere, as it's known, represents the pinnacle of submersion engineering.
Scooping deep into the ocean floor, the excavator represents the pinnacle of modern engineering, extracting vital resources from the darkness.
Emerging from the darkness, the massive boring machine begins its slow, powerful journey, reshaping the underwater landscape 1 meter at a time.
All systems green. Cargo bay pressure equalized.
Confirmed. We are ready to begin extraction.
At depths previously thought unreachable, the Goliath now carves its path, searching for the rare earth metals essential for our technology.
This marvel of engineering, known as the TBM, must bore through miles of sediment, all while surrounded by the crushing pressure of the deep sea. These mechanical arms constantly adapt, guiding the massive cutting head through this unpredictable underwater geology. After months of preparation, the massive boring machine begins its slow, inevitable journey beneath the ocean floor.
The Hercule, as it's known, chews through solid rock miles beneath the ocean floor, a process that generates incredible heat and light.
The deep-sea framework requires absolute precision, a task the new Nautilus class handles with ease. Deep beneath the waves, the tunnel boring machine relentlessly pushes forward, reshaping the aquatic landscape.
The tunnel's pressure-resistant structure, a complex latticework of steel and concrete, glows.
This massive machine is the largest ever deployed at this depth, designed to grind through the seabed at a steady rate, miles from the surface.
Control, this is Alpha. We have positive engagement on the forward anchors. Tension looks good. Bring it down another 20 feet, slowly.
Secured by these massive gray anchors, the structure relies on its thick green epoxy coating to resist the immense pressure of the inky blue depths. Miles beneath the surface, the structural integrity of these conduits is paramount. The green epoxy protects against the relentless corrosion of the deep ocean.
Descending into the abyss, the excavation begins. This massive silver beast must overcome the...
Secure the coupling on beam Gamma 12.
Torque looks good from here. Control.
With laser-guided precision, the tracks for the next generation of bullet trains are secured, marking a new era of undersea travel.
The alignment is drifting point 02.
Compensating with starboard hydraulics. Keep it steady.
Section 4 pressure check is green.
Confirmed. Advancing the bore by 2 meters.
Roger that. Maintaining alignment.
Pressure levels are stable at 400 kilopascals.
Confirmed. The alignment is holding perfectly to the trajectory.
Pressure readings are fluctuating at joint 12.
That's consistent with the microfractures we detected earlier.
Advise caution. The stress load is increasing.
We have a fluctuation on cutter head 3. Adjust the thrust now.
Acknowledged. Increasing pressure.
Pressure readings on Sector 4 are spiking.
Confirmed. Rerouting compressed air to compensate.
R value on sector Gamma is stable.
Confirmed. We are cleared for depressurization on level 4.
Claws are engaged. We have a solid break on the rock face.
Rerouting power to the main stabilizers.
The alignment is drifting slightly to the east. Check the geometry data.
Rerouting the coordinates. We should be back on track within the hour. Section Gamma locking sequence initiated. Pressure holding steady at 1600 psi.
We are approaching waypoint Charlie. Confirm trajectory, engineer.
Trajectory confirmed, Supervisor. All systems green.
Keep the descent steady. Watch the tension on the main cables.
All right, welding team, initiate sequence Delta 9. We need maximum structural integrity here.
Maintaining depth at 2,000 meters.
Power levels holding steady. Increase jet pressure by 10%.
Pressure's fluctuating at the cutter head.
Increase the thrust immediately. We can't risk a stall here.
We have stabilization on the cage. Begin concrete application.
Acknowledged. Commencing spray.
Heat synchronization steady at Mark 7.
Confirming structural integrity on Sector 4. Looking good.
Surface to team, confirm structural integrity at Node 7.
Reading nominal pressure, anchor secure, moving to Node 8. Anchoring these massive cylinders requires unprecedented precision. The cables must withstand the ocean's incredible power.
Segment 4 locking sequence initiated.
Pressure holding steady at 1200.
Confirmed green on all braces. Move to stabilization.
We have green on the alignment. Proceed with securing the segment.
Roger that. Engaging automated sequence.
Readings on sensor array Gamma 12 are stable.
Confirmed. Proceeding to the next junction.
Reroute power to the starboard drills.
Confirmed. Trajectory holding steady at Mark 3. Guide the robotic arm to the alignment point. Ensure the seal is clear.
Confirmed. Locking clamps engaged.
Okay, lower it slowly. Watch the clearance on the curve.
This is the first segment of the Tuncher Tunnel structure.
Winch system holding steady at 40 meters.
Copy that. Pressure looks good on the hydraulics.
Lowering sequence initiated. Maintain alignment on grid reference C-4. Pressure stabilizing. Lowering sequence initiated. Maintain alignment on the east side.
Copy that. Adjusting tension now.
The pressure is spiking on the upper quadrant.
Adjust the alignment sequence now. We can't afford a deviation.
The precision deployment of the reinforcement segments is critical.
Copy that, Command.
Segment 12 is secure and sealed.
Core temperature stabilized. All systems nominal.
Suspended beneath the seabed, this lattice framework represents the next giant leap in underwater engineering.
A triumph of precision engineering. The high-speed train reflects a new era of underwater travel.
All right, slowly lower segment C4.
C4 lowering. Watch the alignment on the east side.
Clear below. Keep it steady.
The structural integrity holds firm, a testament to the advanced composite materials used in the upper sections.
The structural integrity looks solid here.
Readings on the pressure gauges are stable across the board.
Look at the spike here. The waveform is unstable. Confirmed. Alert the surface team.
The sheer scale of the project is unprecedented.
Scanner indicates optimal density. Proceeding to the next junction.
The shimmering effect you see is the immense water pressure managed by this cutting-edge reinforcement system.
Welcome aboard the Hydro Express. We are currently traveling at speeds exceeding 500 miles per hour through the Mariana Trench. A triumph of modern engineering. This sleek silver structure defies the crushing pressure.
An unprecedented feat of engineering. A marvel of engineering, this steel-reinforced behemoth defies the crushing depths. The scale of this underwater structure is awe-inspiring. Maintaining its integrity against the crushing water pressure is a feat of engineering. A monumental achievement in engineering, the tunnel now welcomes its first passenger service. These seismic dampeners, combined with the pressure-resistant steel rings, are crucial. They ensure the structural...
Beneath the waves, we have achieved the impossible.
This project represents a new era of connectivity and engineering marvel.